The line with the equation mx minus y minus 2 equals 0 touches the circle with the equation x squared plus 6x plus y squared minus 8y equals 4. We need to find the two possible values of m, giving our answers in exact form. So, the fact it says about the straight line touching the circle makes me think about intersecting the circle in one place. So simultaneous equations where there's going to be one solution, so we're going to consider the discriminant. In order for me to do simultaneous equations, I'm first going to rearrange to make y the subject by adding y to both sides. So I can now substitute mx minus 2 instead of the y here and here. So we'll still have the x squared and the 6x. My y is mx minus 2 squared minus 8 lots of the y, which is the mx minus 2. And that has to equal 4. Right, expanding these brackets really carefully. Right, we've got the mx squared, so mx times mx is m squared x squared. We've then got the mx times the minus 2, which is minus 2mx, but there would be two of those, so minus 4mx. We've then got the minus 2 squared, which is plus 4. Moving on to the second set of brackets here, we've got the minus 8 times the mx, which is minus 8mx. And we've got the minus 8 times the minus 2, which is plus 16. Right, collecting up some like terms, because we've got the minus 4mx and the minus 8mx. We've also got the 4, the 16, and a 4 on the right-hand side, so we can tidy those up as well. Right, the minus 4mx minus the 8mx is minus 12mx. The 4 plus the 16 is 20. And I'm also going to subtract that 4 from both sides as well. So the 20 minus 4 is 16. Right, now in order for me to consider the discriminant of this equation, I'd like it to be in the form of ax squared plus bx plus c. So first thing I'm going to do is I'm going to group up the x squared terms together at the front. Then I've got the x terms in the middle. And the 16 by itself on the end there. Now, I want there to be an x squared by itself. I don't want to have these two x squareds. So what I'm going to do is I'm going to factorise this x squared outside of those first two terms, which is going to leave me a 1 plus m squared as the coefficient, because the 1 times the x squared is the x squared. The m squared times the x squared is the m squared x squared. By writing it like this, I can see clearly that the a is going to be the 1 plus m squared. We're going to do a similar thing with the x terms. I want to factorise this x outside so it's by itself. So factorising an x outside will leave me with a 6 minus 12m in the brackets, because the 6 times the x is the 6x. The minus 12m times the x is the minus 12mx. And by writing it like that, I can see clearly that the b is going to be 6 minus 12m. And then I've got the plus 16 on the end. So like I say, I can now say that the a is going to be 1 plus m squared, the b is going to be 6 minus 12m, and the c is going to be 16. Now this discriminant that I've been talking about, I know that discriminant is going to equal 0 because the fact that it touches the circle means there's only one solution. So the discriminant needs to equal 0. If it said intersecting twice, there'd be 2 solutions and I'd make the discriminant positive. If it said doesn't touch the circle at all, I'd know there's no solutions, so I'd make the discriminant less than 0. The fact it says touching the circle means there's one solution, so my discriminant is equal to 0. So therefore my b squared minus the 4 times the a times by the c is equal to 0. Right, the 6 squared is 36. We've then got the 6 times the minus 12m, which would be minus 72m. But there's 2 of those, so minus 144m. We've then got the minus 12m times minus 12m, which is plus 144m squared. Right, we've got the, first of all, the 4 times the 16 is 64. And then we've got the 64 times the 1, or rather, sorry, we've got a minus 64 times 1, which is minus 64. And then we've got the minus 64 times the m squared, which is minus 64m squared. I can now collect up some like terms because I've got the 144m squared minus the 64m squared, which is 80m squared. I've got the minus 144m, and I've got the 36 minus the 64, which is minus 28. Now, some big numbers in that equation, so we can simplify by dividing through by 4, I think. 80 divided by 4 is 20. 144 divided by 4 is 36, and the 28 divided by 4 is 7. Now, I could try to factorise that, but it does say giving my answer in exact form, so I don't think that's going to factorise very nicely. So we could either complete the square, or we could use the quadratic formula. The fact that there is a 20 there at the front, I don't like the idea of completing the square. It'll work, but it's a bit awkward. So I'm going to use the quadratic formula. So m is minus b, so minus 36, plus or minus b squared, minus 4 times a times c, divided by 2a, 2 times 20. So that is going to give me the 36. Actually, that on my calculator is giving me, if I do this one step at a time, right, the 36 squared minus the 4 times 20 times minus 7 gives me the square root of 1,856. Divide by 40. The 1,856, the square root of that, well, I can think of that as being, if I was to simplify that surd, that is 2 root. That's 4 root 29. And simplifying that a little bit more, we can divide each of those terms by 4. Sorry, 8. I misread my calculator there. That is 8 root 29. So yeah, dividing each of those terms by 4 gives that, and I think that's as simple as I can write my 2 possible values of m in exact form. So 9 plus 2 root 29 over 10, and 9 minus 2 root 29 over 10.